Hello, we're going to talk about the industrial edge outlook for 2022 and beyond. I have with me Jason Andersen, Vice President, Strategy and Business Lines at Stratus Technologies. I'm Mark T. Hoske, Control Engineering Editor and Content Manager since 1994. Jason, welcome and thanks for today's discussion. By way of today's introduction, would you want to mention a few things in your background and experiences that help with your current role?
Oh, sure. Yeah. Thank you, Mark. So like you said, I lead strategy and business line management at Stratus, which is a fancy way of saying, I guess, product management and deciding what to do with our product lines, how we market and position them. I've been in the computer industry now for actually 30 years. And primarily, I joke around, I've been to Stratus 9 years, and I say, well, I've spent most of my career in the software industry. But now I've been here long enough where maybe it's seen I'm working for a systems company like Stratus. It's more of a hardware type of job. But the fact of the matter is that all of our intellectual property and most of our skill set in the company actually sits in the software space. We just happen to package it up and deliver it in hardware-based systems. So, but my focus has always been heavily on the outside world and bringing it into companies. So a lot of market research, a lot of time in the field, a lot of time trying to understand customers' needs and bringing them back, ultimately leading to new products, new offerings, different ways of looking at the industry and trying some new things, which is kind of where we ended up where we are today at Stratus.
Great. Before we hit the title and the main topic of the interview, first perhaps explain and define what Stratus understands as the industrial edge.
Yeah, that's a good one because there's many types of edge out there, right? And it does vary from market to market. The edge definition in something like the healthcare industry or retail is quite different than industrial and energy. We focus our attention on the industrial edge, which effectively means anywhere where general purpose computing is being done outside of a data center or cloud implementation. And generally, we'll talk about the industrial segments like manufacturing, energy, such as oil and gas and renewables. We also focus a decent amount of our time around transportation, things like rail. We do a lot of stuff in airports and things like that as well. So those are kind of our big three areas for how we describe the industrial edge.
So what all is wrapped up in there? I mean, I've heard a lot of terms like industrial edge computing, networking on the edge, sensing. What else? I've also heard of terms like thick and thin edge.
Oh,
Could you please explain a little bit more?
Well, the thick and thin distinction is actually one of the things that maybe you said you were missing. Thick and thin really is how much of your, let's call it compute work, is being done locally near the work itself versus how much of it's being performed in a remote data center or in a cloud. Effectively, the work that needs to be performed, which I'll talk about in a second, is roughly the same. The question is, where do you do the work? And depending on the situation, it's very advantageous to want to do the work maybe closer to where the work is versus far away. So a classic example is if you're doing something like a machine learning type of installation. Maybe you're doing machine learning for maybe a park or a city or something like that, and you're trying to understand traffic flow. You can actually put a lot of really kind of small internet connected, fairly cheap systems out in the field and deploy them, and you're just taking pictures kind of, maybe you're taking a picture every 15 seconds or something like that to learn what's going on about the traffic flow. That's a very good thin edge example, right? I have a small device that is doing some sort of processing, but largely that processing is being shipped somewhere else and handled somewhere else, so namely in the cloud, usually with machine learning. The flip side of it is that there's thick edge, and thick edge is where you start to have a lot more of the computing being done close to where the action is. And a perfect example of that is actually like manufacturing floor types of scenarios where you have a lot of maybe potentially multiple applications that are touching a specific process in terms of maybe turning a raw material into a finished good, or in terms of moving something from one part to, onto the, from maybe the warehouse onto the truck or onto the forklift or something like that. And all of those use cases tend to be fairly closely watched by maybe local people. So you're not going to round trip your data back to the end user when the end user is already there, the operator's already there. It could be that there's a real-time component, like a safety system. It could, or robotics situations where you don't want a robot to kind of, commit some sort of error. It could also be a situation where there is a high regulatory component. So for example, we work with a lot of gas companies who put in fairly hefty systems at the edge because they want to keep the data. There's a lot of data that happens, and they want that data to remain pristine. They don't want to put it somewhere else. They want it to be there in case there's some sort of failure. They know where they can start the process of understanding that. And there's also sometimes a compliance or a regulatory component to that. So those are the types of scenarios where you're going to put thick edge, which you're going to put more of the computing power near where the actual process or the work is being done. In terms of, industrial edge computing, to bring it back to your first part of the question, really it comes down to, we tend to look at it from a perspective that's a little more futuristic, which is we're putting IT type devices that are general purpose compute devices out at the edge, and you're deploying that along with even general purpose things like industrial Ethernet or standards based types of networking systems. So that's another great example of industrial edge computing is industrial networking. There is a lot of sensors out there. There's a lot of things like PLCs out there that can either be hard PLCs or soft PLCs deployed on general purpose compute. And as well as now you're starting to see an increase in security types of software and or hardware being deployed, or security software being deployed on general purpose hardware at the edge. So there's a lot of different types of capability there. But when we talk about it at Stratus, we specifically are talking about the general purpose kind of IT grade computing versus something specific to, say, a DCS system, which may have PLCs dedicated to it. That's a kind of a different type of model. It's a different type of stack, actually.
Great. Well, that gets into the next question a little bit, and that is, how does the industrial edge differ from distributed controls or other controls and automation architectures?
Yeah.
And then does the approach vary by industrial market?
Yes and no. I'd say that we're kind of approaching an inflection point in the industry where right now they coexist, right? So a great example of that is distributed control systems are big proprietary kind of monolithic stacks. But what you're starting to see is vendors who sell those, the industrial automation vendors, are beginning to put more general purpose componentry into them to make them a little bit less proprietary and more agile. So you could deploy a system with, say, instead of running the compute on, say, a standalone piece of hardware that was built and manufactured to spec for that, now it's starting to happen as people are taking systems and deploying them in a general purpose way with, say, technology that will let them add more computing to it, more applications, or even support different types of processes from the same system. So they're becoming the line is beginning to blur a little bit. But the truth is that I think edge computing is really dominated by like general purpose. I'm going to put a compute device out there and I can put whatever software I want on it for my factory floor or for my oil rig or whatever, and it's just going to work, versus something that's a little more proprietary, like the distributed control architecture type of model of the past.
You mentioned some different applications. Does the approach vary by industrial market?
Oh, for sure. I mean, if you start to look in places where like it kind of trails with the software, to be honest with you. So, for instance, industrial edge computing in places that deploy like SCADA systems versus DCS in terms of control architecture, SCADA already has been on this path for a very long time, and they because companies like Wonderware, for example, and Aviva, who are big partners of ours, those partnerships, they've always kind of said, we're a software company first, deploy it on whatever hardware you want. Stratus adds value to that ecosystem by saying, well, you could, but we have a different class of hardware that provides a different set of capabilities than, something off the shelf per se, right? So even though we still run the same operating systems, we have different capabilities, right? So I'd say that if you look at, discrete manufacturing is definitely warming up and kind of moving away from the more proprietary approach. Certainly energy absolutely is going through that transition, especially renewable is really built kind of from a edge computing first versus deploying the older type of stuff in the industrial space. So renewables, oil and gas is still a mix. Transportation still a mix. So I'd say that almost every vertical we've met with, especially in the industrial space, has said, hey, I want to do something that's more open, standards-based, more IT friendly. It's just a question of where they are on the journey. And like I said, some are further along. And my argument is they're further along because of the software choices they may have made 10 or 20 years ago, even, believe it or not. But now they're finally kind of coming around the corner to, oh, wait, this is different. We can do something a little bit more kind of a refreshed design in some ways.
So given that look back, what's the outlook for industrial edge in 2022 and beyond?
Well, we've been talking about this for a long time. Stratus, we've kind of come up with this, we call it the 5 I's, right? It's kind of a maturity model for where you are in the edge journey. And the first one being what we call isolated, right? And the last one being invisible. Okay. So I won't bore you with the other 3 in the middle, but the isolated is essentially kind of the idea of what DCS was, is I deploy a distributed control system. It manages that factory or plant or site, and it kind of runs by itself. And it's, guys like Gartner call it autonomous computing, which is funny because they consider that because it's not connected to anything and it kind of takes care of its own needs, it's autonomous, right? Which I guess makes sense on some level. The other side is what we call invisible. Invisible to us is actually our definition of autonomous, right? Which is the exact opposite of Gartner, which is you deploy a system that actually takes care of itself. It is highly connected because it allows the system to be able to adapt to changes, and it allows the system to be able to use AI technology to kind of ultimately, change things and or stop things or manage things largely on its own with little human intervention. To us, autonomy isn't just kind of the fact that it sits on its own island. It actually is very capable, right? And so if you look at those as the 2 opposite ends of the spectrum, we're really kind of at the tail end of the second phase, which we call the informed phase, which basically is, hey, I'm starting to get really good business data out of this thing. I'm getting good analytics here. But now what? Now what? How do I actually take advantage of that? So I'd say the last few years have really been about how do we deploy technologies like analytics or predictive maintenance, asset performance management, all these very data intensive applications, just so people can figure out where they are and how they can improve. We're now starting to move into the next phase, which is really, okay, now that I have that information, what are the types of transformational steps I can make to do that? And where this collides, and recent turn of events have made that collision even more impactful, if you will, is, okay, well, now that I start to realize that I have this good information and analytics, and now I want to put in systems that are more agile, reactive, ability to take on the business transformation requirements that are coming in terms of new products and offerings we want to deliver. Now that that's happening, now I need the operational people, now need the technology people, the IT people more than ever. And it just so happens that while all this is happening, we have a global pandemic, which forces remote work on people. And now we have somewhat, I would call it geopolitical uncertainty, for lack of a better term, with what's going on in Europe right now, which is throwing up major concerns about cybersecurity. So all of a sudden, the IT value proposition to the OT people is greater than it's ever been. And there's this need for them to work together. And the truth is the funny part is that need, while maybe has been driven by external forces, from a technology maturity standpoint, they were already kind of getting there anyway, right? Because of this, hey, now I understand that if I more actively manage the temperature of my ceramics firing kilns, right, I can actually save a ton of money. Okay, well, how do I do that? Well, you need more IT to do that. And so now all these things are kind of colliding together at this really kind of fortuitous moment in the industry.
Well, that's great, because that leads right into the next question. And then what are all of the market drivers contributing toward these industrial edge trends?
Well, I mean, I think a good one is it's kind of funny because I think that the supply chain issues around the world are really putting a huge underline in terms of how will people kind of continue to deliver the same level of products and services that they had pre-pandemic. So I think that's a big driver, but I also think that's kind of one of those things where, is that going to be kind of initially an inhibitor? Because look, I can tell you, there's a lot of people scrambling around our company right now, just trying to make sure we get the right parts on the right trucks to the right people, right? So there's a lot of tactical stuff going on in that sense. But in terms of a driver, I do think people are saying, how do I make sure this doesn't happen to me again, right? So I think that's a big driver. I think the nature of people's relationship with work has changed significantly in the last 2 years, in the sense of, there's less workers, right? We definitely are seeing people leaving industries, right? So that's a big deal, especially operational technologists, because when I was in engineering school, I didn't look at industrial engineering because I was looking at computers and high tech. And so, there is definitely a kind of a big gap. There's not an easy transition away from the operation technologists. There's a lot of, in the United States, we call them boomers, right? A lot of boomers moving out, not a big field of people in the next generation coming in. So it's being handed down to people maybe 2 generations removed, which creates a new set of dynamics in terms of expectations of work, expectations of technology use within work. Those types of things it's a huge driver. Then there's the whole aspect of, how does remote and hybrid work impact this? Maybe not for the person working on a manufacturing line, but maybe for the technologists operating those and monitoring them, ensuring that they continue to work, the right business analytics are being met. So remote work. And then I think there is this whole, I think everybody started to breathe a little bit of a sigh of relief around COVID this year. Like, everybody kind of went into this year like, this year is going to be different. 2022 is going to be different. Then we got a war going on in Europe, right? So I do think that there's a whole mess of people going, okay, now that we've been through this kind of very difficult trial period and the rules have changed, what will our strategy be to do that? And that's where digital transformation projects really kind of start to come to light, which is now people are forced to reckon with the fact of, oh, I really do have to create a new normal. I really do have to do things differently, or I really have to re-examine my supply chain because, am I either on either side, right? Which is, am I still going to be able to sell products where I think I can sell them, or am I going to be able to get pieces and parts when I need? I mean, there's some really strange behaviors going on in the supply chain right now in terms of component shortages and people profiteering off of that and things like that. So, yeah. It's kind of a funny time because there's all this tactical behavior just to kind of manage through. And the companies that win a few years from now, the companies where, if we get in a time machine 5 years from now, 10 years from now, the companies that are going to come out of this winners are the ones who are going to be able to say, okay, I understand that I have this tactical set of problems I have to solve, but how do I ensure that next time around this doesn't happen again? Or how do I ensure I'm positioned well for the next thing? And that's really where we think, trying to tie it back to edge computing is, edge computing and general purpose compute and solid IT practices delivered at the edge is a great way to facilitate those types of strategic desires. Right.
So are the customers for industrial edge products, software, and services different from those interested in automation and controls?
A little bit. What it is that I think that the role of the machine builders and the SIs is changing. So I think that there was what's the best way to describe it is
SIs, system integrators.
Systems integrators, yeah. I'm sorry. So I think there was a time where if you were a manufacturer and you had a factory and you were trying to improve the factory or add a new line to the factory or add a new product offering to the factory, you would, in the United States, you'd open up your catalog and say, well, geez, I got a lot of Allen Bradley or Rockwell stuff. And I'm just going to call my Rockwell guy and he's going to come and tell me what to do. Right. And then, of course, the Rockwell guys would show up. And I'm not picking, or the Rockwell's our #1 partner in the world. So this isn't me picking on Rockwell because they've done a lot of things to adapt their business over the last few years to actually really solve for this problem. Right. I'll get to the solving for it in a second. Is they would come and say, here's our stuff and come in and do this. And they would do it. And they, maybe they'd bring in some systems integrators to come in and build it for you. And that was great. Now what's starting to happen is people are saying, well, wait a second, maybe I've acquired a new factory that isn't a Rockwell factory. How do I make sure this stuff begins to interoperate together? Or how do I kind of be able to manage multiple sites, or manage across my supply chain, who have all different stuff and all different technologies, and there's no good way to get the data out of anywhere, right? So what's starting to happen is that the customers used to be, it was really safe to go, I work with this particular automation vendor and they provide me pretty much everything I need. That isn't the case anymore, right? Either because of business choices they've made or because of the technology evolving, right? Maybe you're in an industry that doesn't have necessarily the right software from that vendor. Well, who do I turn to for that software? And is that software interoperable with my existing plant of PLC sensors or whatever, right? So there's been this shift in thinking, and what's started to happen is that the independent systems integrators are becoming a lot more consultative. They're becoming a lot more solution oriented. At the same time, the people who build the machines are starting to build machines that are a lot more, they're more modular, so they're able to attach to each other more easily. And the machines that are out there are also becoming smarter. So therefore they're able to kind of produce data and integrate with other machines, and even machines not from them, in a different way. So there's all these two groups of ecosystems are starting to have a lot more customer. They're no longer viewed as kind of like the guys who just get it done. They're now much more strategic in terms of what they can offer a customer, how they can talk to a customer, in terms of who the end customer ultimately listens to, is starting to shift. And that's a huge change. And the funny part about this is that it's all happening, and the traditional IT vendors, which is kind of where Stratus comes from, they're kind of still approaching this like, I'll just call the CIO and he'll buy a bunch of computers for me. And it's like, no, no, you got to figure out how your thing fits into their ecosystem, their machine, their everything else. So I think this is a funny one, because I've been, like I said, I've been in technology, high technology for 30 years, and I've been through all these seismic shifts from e-commerce to virtualization to cloud, all this stuff we were working in. And this is different because it's not like the computer industry is going, we know what's good for you, you're going to go do this, which is kind of how it's worked in the high-tech computer industry for a long time. This is much more like very solution-centric, very, in a lot of cases, fairly customized.
So you've addressed some of this, but how does the specification, integration, implementation, and use of edge technologies compare to automation and controls?
Well, it's more flexible. I mean, you can go and say, let me kind of pick and choose the parts that work best for me. So I think that there's an element of that. The ability to change it is easier in some cases, because some cases now, like if you've turned everything into kind of more software driven than hardware driven, if the software changes, you can change it, you can deploy it, you can redeploy it, those types of things. So I think the big thing is flexibility on the compute end versus an automated control system. That there's also if you're using certain scenarios, it's cheaper, right? So you can save some money because you don't have to buy a monolithic stack from one vendor and be beholden to that vendor forever. So you do have the end user has a little bit more leverage in the situation. So I do think that those are two kind of major differences. The downside, which you got to watch out for in these situations, is time, right? Because if you buy from an automation vendor, they'll support it forever, right? Whereas your typical IT vendors, we're not like this. We tend to kind of support. We have a longer life support cycle, and we tend to do more sustaining engineering than kind of your traditional IT vendor. But traditional IT vendors like to have really tight timelines, right? They want to get you to buy the new stuff, and they want to keep you moving. Whereas the length of relationship is a different thing. So that's the big plus side for the automation vendors, is that they're able to, they're with you, for a longer stretch of time than in the typical IT technology scenario, where a refresh cycle might be 3 to 5 years versus say, 6 to 10 or 6 to 10, 12 years, right? Which is what you see here in the US on the automation side.
Sure. Yeah. And that gets to the next question, which is, does maintenance for edge technologies differ in key ways from those familiar with automation and controls, and what they might expect for that?
Yeah, I think that there's a difference. I think there's a heightened expectation from the operational people who buy from automation systems about compatibility as well as serviceability. I think those are two major things where in the IT world, it's kind of less people, because IT tends to push the limits a little bit more what technology can do. So therefore, there's this kind of inherent willingness to experiment and try things differently and, you know, make some mistakes along the way. And overall, over time, it kind of works itself out. Whereas when you're building a new factory that's going to drive, you know, millions or tens of millions or billions of dollars worth of product over a course of, say, 10 years, you want to get it right the first time. And if something does go wrong, they want it to be fixed right away, if it has to be fixed at all. So I do think that, you know, things like reliability and serviceability come into it big time. I think the other aspect of it is there is a different type of challenge that's not a technology challenge, which is the people challenge, which is, you know, everybody in the automation world has heard the stories about the guys who could walk up to, like, being an oil refiner, they can walk up to a pipe and touch the pipe. And they know by touching the pipe that this thing's going to need maintenance in a couple of weeks, right? Well, that guy's no longer there. That guy's been replaced by a very capable person who just got out of college 2 years ago and doesn't know how to touch the pipe, or maybe doesn't want to. They want to be on their iPad and just look at the data and figure it out, right? So I do think that there is this notion of the user, and when I speak about the user, I'm not talking about the corporate entity that buys the technology or solution. I'm talking about the specific person who's a driver, operator, end user of the technology. Their expectations and job skills and time in the market's completely different. And I do think that that's something that has to be taken into account. Like, I will say that, you know, if you look at some of the newer offerings from some of our partners, like Rockwell, for example, I mentioned them because they kind of in the United States represent the old school, but at least they're trying to put some new offerings out and some new software out to show that they can kind of bridge the gap between the past world and the future world. So they've done a good job of that. They also do some pretty cool things with services. And I think that's the other thing, is that the last piece of the equation, I guess, to this question is, there's going to be some more willingness to outsource different types of services because of the hiring gaps right now. So, you know, you may have said, I will never, ever, ever outsource predictive maintenance to somebody else. You might be more open to that now that you can't hire anybody to do it for you. So, you know, I do think there's an element of people being able to do more, you know, systems integrators and other vendors being able to provide more managed services and more outsourcing capability in the market over time. And that's going to change the dynamic of how you manage your factory and your plant. Because people are already outsourcing machines, right? That's happening now, right? So why not outsource not just the machine itself, but the actual operation of that machine to somebody else, a vendor you trust, right? I don't know, you know, then you get into all sorts of issues, because like as soon as you outsource it, how do you arbitrage? And, you know, there's GPDRs, all kinds of legal crap. But the point is, I think it could happen. And I think it already starting to.
So are the go-to-market strategies different for edge technologies? How do people get these products and services, and how might that differ than what they're used to?
Well, again, I do think it comes back to what I said before in terms of who do you take your advice from, right? And how is that working? And what I mean by that is, if you used to be affiliated with a certain vendor or a certain vendor ecosystem per se, you might have just been easy enough just to call that vendor. Back when I started my career in computing and IT, you know, there was a saying, you never got fired for buying IBM. And I got to see firsthand why that was true. My first place I interned was a huge IBM shop, and something broke. I don't remember what it was. Literally, the CIO called the IBM guy and was like, this is broken. And they had a guy there in like half an hour and he fixed it. It was like, oh, okay. Well, now I see why, you know, and the guy CIO pounded his chest and told me, that's why I buy from IBM. Right. And I was like, oh, okay, cool. Right. But, you know, I also spent a decent chunk of my history in open source software, right, where, you know, it was very innovative, very new, lots of problems, not necessarily enterprise ready in the first day type of stuff. And I think the takeaway from that is that where advice is coming from and how it's received is completely changing. And that's kind of what's going on now. Whereas you're not going to necessarily only look to one vendor to build you an entire solution. You might look at, multiple vendors, or you might look at multiple vendor. You might be looking at a team of people working around a vendor who are going to recommend to you the best solution for you. And I do think that there's an element of that. And I also think there's an element of partners of those major vendors are also starting to define solutions of their own. A good example of that is we work a lot with people who embed our technology into other technologies, machines and skids that they build, and we deploy them in, right? And so that would be, well, geez, I don't want to go to vendor X for this. I want this thing from you, and then I want this other thing from you. And by the way, you two make sure it's all compatible with this, right? So I think that's happening more and more.
Would it be useful to discuss certain customer implementations or real world examples to help people understand how edge technologies might be able to help them?
Yeah. So yeah, for sure. We deal with a fairly diverse base. And I think the one I just kind of hinted at was a good example of that. Is that this company called Streamline Innovations, and they build energy abatement types of systems. And what they started to realize was, okay, I build this system, I put it on a skid, and I sell it to a customer. Now, how can I add more value to that, right? Add services, add products over time, those types of things. And how can I also provide, understand the system itself in terms of the types of data that's being put out, so we can do better diagnostics and things like that. So they actually deployed, we a couple of years ago, we came out with a system called ZTC Edge, which is a kind of a machine device, right? It's a dual node compute device that gets mounted directly onto a skid or onto a machine. And it does all the computing for that particular device. And it has the ability to share that information with other machines, or you can pump the information to a cloud if you want. But it's really kind of built around the model of, it's kind of inspired by consumer technology type of thing, where it was like, you buy it, it shows up, you plug it in, it's ready to go. There's no like, oh, now install this software, now do this, now do that. It's really kind of, you plug it in, you get it set up, it's up and running quick. So Streamline's a really great partner, because basically they embed our technology in theirs, and they make it really easy to use and hand it off to their customers. Then there's another company, interestingly enough, called Rubberlight, and they make foams and polymer-based foams, and they're in the southern part of the United States. And they essentially have built their own infrastructure, built their own architecture, and they use our servers and deploy those on the factory floor to essentially provide things like HMI capabilities and SCADA and those types of things. So it ensures that the factory continues to run very well. And they use our more kind of IT-ish offering, I'll call it, which is the FT server product. And like I said, they're an end customer. So they buy direct, they'll buy technology. They'll generally go to a systems integrator or a VAR of some sort, and they say, listen, I'm trying to build this myself, and here's the pieces I need. And they give a spec and they hand it to them. And they're a little bit more traditional, whereas like Streamline, a customer might not even know we're embedded in them. They have no idea. Just they're buying kind of a canned solution from Streamline, which Streamline's not canned. It's kind of like an 80-20 type of thing. They do some configuration and some consulting with it to make sure it fits and integration work, but they're essentially buying that as a whole. So we kind of have a couple different business models we subscribe to. We have the direct end user model, where the customer is really designing it themselves or in concert with a systems integrator, and then we have the embedded business.
So what's next for edge technology developments? What can people look forward to?
Well, it really varies. There's a lot of attention going into, like I said, there's still a lot of attention on the collection of analytics and collection of data. And depending on the type of data, that drives a couple different scenarios. For instance, like real-time computing, which is incredibly fast, high transactional type of data. That's a space. The visual data, so you start to see like GPU technology being integrated into edge systems. So that's kind of the space on the collection side and data ingestion side of things. We're certainly seeing a trend in edge computing where when you're deploying the compute out, Used to be you deploy an industrial PC out in the market and be like, oh, that'll do it. Right now, we're seeing is this demand for either technologies like virtualization or containerization, which means that you put a bigger computer out and it replaces the need for 10 smaller computers. So you're starting to kind of scale up the technology. So you're starting to see the industrial edge start to really gain some scale, because just if you think about it, some of these machines, like I mentioned, Streamline and other vendors like that, what they're realizing is they can deploy a general purpose compute node out there with just enough to run the machine. But when that customer says, well, geez, I'd like to run that machine remotely, or I'd like to run that machine and get more analytics out of it, or I'd like to run that machine and do something else. All these vendors are going, well, I want to sell a machine with the capacity and be able to kind of maintain that relationship with the customer and frankly, sell them more capability over time. So that's where it starts to get to higher scale systems with technologies like virtualization. So that's the core compute. That's the actual computing versus the ingestion. And then the last mile is the connectivity and we'll call it big processing, right? Which is your cloud, AI, analytics types of situations where your core compute needs to have the ability to connect, make sure that that connection is secure, as well as then be able to put the right data into the cloud, because the thing about the cloud is that it can get expensive. You just push all your data up there randomly. So what you want to be able to do is process it efficiently at the edge, move it into the cloud as efficiently and securely as possible, and then have that be processed. So really, the kind of industrial edge compute system sits in the middle of the whole thing. And that's kind of where it gets scary, because that becomes a bottleneck. IT gets very interested in making sure that's secure, reliable, serviceable, all those other things that IT cares about, that essentially, but it sits at the heart of the whole thing. So you have to be mindful of the two polar opposites of ingestion and ultimately in that analytics and consumption.
Are there other things that you'd like to discuss or recommend as we finish up? And please tell us where someone can learn more.
Yeah, for sure. So obviously, couple quick things. I do see that as people want more scale and they want to do more stuff, you're going to start to see more advanced IT concepts coming down the pike. So we're starting to see customers dabble with like hyper-converged and private cloud technology at the edge, especially big places like massive manufacturers, hundreds of thousands of square feet facilities, type of stuff like that. So I do think that whether people like it or not, the cloud is coming. And the good news is it's not going to be all in one or all in the other. It's definitely a cooperation between the edge and the cloud. And I think that that's a big change in people's thinking, and people will have to continue, especially the edgy people are going to have to evolve that thinking and get over the cybersecurity fears, because that's manageable as well. And so that brings me to cybersecurity. That's the other huge area, because you don't really get, the strangest thing to say is, again, an autonomous solution, as Gartner would say, isn't really the right way to look at it, because that basically means it's isolated, as we call it. Autonomous is really something that's able to take care of itself, and it takes a village to make something be able to take care of itself. If you had an autonomous vehicle, the last thing you'd want is for the autonomous vehicle not to know that the light is red at the end of the street. You want to make sure that autonomous vehicle is going, hey, should I stop here? and that street corner should be coming back going, you should probably stop. All right. So that autonomy to us is connectivity. And connectivity requires privacy and security. So those are the two big areas where I spend most of my time thinking about is effective scaling and cybersecurity. In terms of getting more help, well, it's simple. Stratus.com is a great resource. We provide a lot of information there. And we also have the ability to locate partners who are, we work with, in the United States, for example, over 100 partners, actually more like 200 partners, I think, who really super smart on the big picture outside of the industrial compute. So you can find a partner there and begin a dialogue with them, or start a dialogue with us.
Well, thank you, Jason Andersen, Vice President, Strategy and Business Lines at Stratus Technology, for the discussion and perspectives and insights on industrial edge outlook for 2022 and beyond. I'm Mark T. Hoske, Control Engineering Content Manager. Thanks for joining us today.